Hello all, welcome to iTutor Academy. In today's session, we will start with the Unit 15 subsection 3, that is examining the fitted straight line. Okay, so in previous videos, we already discussed the history of this. So you just revise that, it will be more easy for you. And in fitting the liner model, that is why it's equation based, using the least square criterion as indicated above in section 15.2. Already we discussed in last video 15.2. If you have any doubt, you just refer that. And no assumption were made about probability distributions. The method of estimating the parameters tried only to minimize the sum of squares of the errors. You just note down this. Actually, the explanation you just this video you just go through with your IGNOU study materials, then it will more clear for you. Okay, and you just once read that, also it will help you for your more understanding. And the method of estimating the parameters tried only to minimize the sum of squares of the errors or residual, and the simply involved the solution of simultaneous linear equation. Okay, however, in order to be able to evaluate the precision of the estimate parameter and provide confidence intervals for forecasted value, it is necessary to make the following assumption in basic model. Okay, so this is the equation based models are there. And it may be mentioned here that errors that occur in many real life situations tend to be normally distributed due to the central limited theorem. In practice, an error term such as this is a sum of errors from several sources. Then no matter what the probability distribution of the separate error may be, their sum will have a distribution that will tend more and more to the normal distribution as the number of components increases by the central limit theorem. Using the above assumption, we can determine the following. One is standard error of the slope b and a confidence interval for beta 1, and standard error of the intercept and the confidence interval, standard error and the prediction value, significance of regression, percentage variation explained. Standard error to be slope and confidence interval for its estimate. So from the equation you can understand that. So you just go through these equations. Okay. One figure also here, this is a t distribution, figure 3, standard error of the interception and confidence interval for its estimate. Okay. So you just go through your IGNOU study material, and the standard error of the forecast also explained here with the equation, and it will more clear for you. And the F test for significance of regression. Since the y are random variable, any function of them is also a random variable. Two particular functions RMS are the mean square due to regressions, and S square, the mean square due to residual variation, which arise in the analysis of variance, that is table on 15.2. Percentage variation explained also here. And the next is an example of the calculation. So here is an example. The various computation outlined in the case of a straight line regression situation, that is on 15.3, will now illustrate the example of annual sales data for a company that was considered earlier in section 15.2. Recall that fitted regression equation, or you can just refer the last video for 15.2, and this is the example from a company. Okay, go through this section with the example. The theorem is more clear, so go through this section. And confidence limit about the regression line also here, activity also based on example is here, and here is the F test for significant regression also explained here. And next is variety of regression model. The method of regression analysis have been illustrated in this unit for the case of fitting a straight line to a given set of data points, and however the same principles are applicable to the fitting of a variety of other functions which may be relevant in certain situation highlighted below. And seasonal model, the monthly sales for item like a woolen or desert cooler is expected to be seasonal, and sinusoidal model would be appropriate for such a cases. So this is the cyclic demand and cyclic forecaster. The picture is here, that is chart based figure, and a seasonal model with the trend. When in addition to cyclic component, a growth or decline over time of the demand is expected, a cyclic trend model of the following kind may be more suitable. And revenue miles followed and a linear cyclic forecast. This is chart based explanation is here. Polynomial of various orders, and multiplicative models also here. Often by a simple transformation, a non-linear model may be handled by the methods of linear regression. And linear and non-linear regression, we have seen above that many non-linear models can be transformed to linear models by simple transformation. It is to be noted that we are referring to linearity in the unknown parameter, so that any model which can be expressed as equation is called a linear, and which such a model is parameters can be obtained by the method of least squares as the solution to a set of linear equation, that is normal equations. And non-linear model which can be transformed to yield linear model are called intrinsically linear. Some model are intrinsically non-linear, that's also example also here. So summary of this chapter is here. In this unit, the fundamental of linear regression have been highlighted. Broadly speaking, the fitting of any chosen mathematical function to given data is termed as regression analysis. The estimation of the parameters of this model is accomplished by the least squares criterion, which tries to minimize the sum of squares of the errors for all the data points. And how the parameters of a fitted straight line model are estimated has been illustrated through an example. After the model is fitted to data, the next logical question is to find out how good the quality of fit is, and this question can best be answered by conducting statistical tests and determining the standard error of estimate. This information permits us to make quantitative statements regarding confidence limit for estimate of the parameters as well as forecast values. An overall percentage variation can also be computed, and it serves to give a score to the regression. Thus, it also serves to compare alternative regression model that may have been hypothesized. The various computation involved in practice have been illustrated on an example problem. Finally, it has been emphasized that the method of least square used in linear regression is applicable to a wide class of model. In each case, the model parameters are obtained by the solution of the so-called normal equations, and these are simultaneous linear equations equal in number to the number of parameters to be estimated, obtained by partially differentiating the sum of squares of errors with respect to the individual parameters. Regression is thus a potent device for establishing relationship between variables from the given data. The discovered relationship can be used for predictive purpose. Some of the model used in the forecasting of demand rely heavily on regression analysis. One such class of model called time series model is explored in Unit 20, and this is self-assessment exercises here, and you just try to do this. It will help you for your term and examination. In case any doubt, you can contact us also. We will help you. And keywords are here in the section. If any word is feeling difficult, you just refer this section, and the explanation of this word is also here. And for more IGNOU MBA videos, you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents IGNOU MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.